Hello and welcome to this Adult Education Senior University session, Astrophotography of the 2017 Solar Eclipse, with presenter Jon Aros. Jon began his journey in science prior to high school with a telescope his uncle and parents purchased one year. The telescope fueled an interest in photography. Over the next several decades, he always found time for both, in addition to life's path, school, family, etc. Jon has taught chemistry and astronomy for 20 years, bringing 30 years of experience to both subjects. Jon's proficiency in astronomy allows him to work on a research telescope in the local area. His enthusiasm in astronomy and a casual discussion between friends ignited a personal project which drew him to the path of totality in 2017. Jon is also preparing several more projects, which include meteor showers, the 2024 solar eclipse, and heightened solar activity throughout the latter part of the new decade. Welcome, Jon. We appreciate your taking the time to be here with us today.
Okay, I'm Jon. Welcome to the presentation for 2017 Total Solar Eclipse. The first part, there is no audio, so I'd like you to read the first several slides. Okay, so everything you just read about was what happened to us on the way there. I had gotten to the point 3 hours prior to the actual eclipse where I didn't think we were going to be able to capture a single image. And so it was very disheartening. I'll tell you that if you look at this picture very closely, if you see the counterweight at the bottom right, we have a large camera lens at the top. Underneath that camera lens are two astronomical telescopes. One is for what we call the infrared or the near hydrogen alpha, far side of the IR. And we also have a visible light telescope. If you notice at the bottom here, there's two weights, but sandwiched between them are two weightlifters' weights. It turns out that the original idea we had was to attempt to measure the lensing effect and how far from the solar disk it occurs. However, I became focused and sort of obsessed with that particular measurement. And in the several months leading up to the eclipse, I completely forgot about the counterbalance. And so I had built the mount out of wood, knowing that there was a possibility we might have to make a modification somewhere. Being that far west, without having any power tools, the only thing I had on me was a Swiss Army knife that has the jagged teeth with a little branch cutter. And so I began sawing the mount apart with a Swiss Army knife and taking out all of the components that added the additional weight that we could not get to balance. And so that was a little bit daunting. As I was working that evening, the owners of the RV park had a golf cart. They were driving past. And he stopped by and he said, "Is there anything I could get you?" And jokingly, I said, "You wouldn't happen to have a set of plate weights, would you?" And he said, "Absolutely." He said there was a guy who stayed there who was a weightlifter. And when the gentleman had left, he had left the weights behind. And I said, "You wouldn't mind grabbing them, would you?" He said, "I'll be right back." And so he came back and I borrowed several of the weights to achieve the counterbalance. You read that the spot they had picked out for us was sort of shoved in a corner. And if you look at this particular picture, you'll see the end to the bottom or to the right-hand side of the image is my friend's vehicle, one of my friends that I met up there. And on the other side of him is a set of railroad tracks. And trains out west are much larger than the trains we see here. So here we have 2 or 3 engines. Out west, they have somewhere between 4 to 6 engines. Many trains here are 150 to 200 cars. Out west, they are 400 to 500 cars. And so if a train passes and there's vibration, the ground is hard, that vibration gets transmitted to the mount. So I'll call your attention to the very bottom of the mount at the bottom of the 3 legs. We didn't know that we would be in a place that had bathroom facilities. And so we brought our own portable outhouse and plenty of toilet paper. And so I had no idea what to do with this vibration problem. And it hit me that maybe what we should do is just take 3 rolls of toilet paper and stick it under the mount and hope that that cushion was enough to absorb the vibration from the trains. We didn't have any idea whether or not that was going to work or not. Also, my friends took a picture of me asleep, which frustrated me a little bit. Casper, Wyoming. This is the statistics for it. It's 42 degrees, 51 minutes, and 59 seconds. You read that the mount had to be adjusted. The particular mount that I have handles a fairly large weight of optical gear on top. In order to handle that weight, there are preset positions. Those preset positions have to be adjusted. And it just so happens that one of the lower preset positions is 40 degrees. That means that as we're dialing the mount to do an alignment, we can't get to 42. And so we have to pull the bolts out. And so by the time we were done, we were exhausted. I was certainly exhausted already. I was sitting there and I didn't really want to do much more. And then Andrew turns to me and says, "You're not going to believe this, but I just checked the weather." And I said, "Okay." So now let's take a look at what the mount looked like originally prior to the modification. In attempting to make some measurement on the lensing effect, you'll see that there are several cameras on top. And I'll show you a zoomed in version of this on the backside. Those 4 cameras and lenses on top. If you look at this picture, I didn't think about it as I was working on it, but when you look at this, it's very clear that all of the weight is at the top And if you look at the two small counterweights at the bottom, there's not much counterweight there. So I became obsessed with this measurement, and I completely forgot a basic concept in physics, which is center of mass. And so that's what I needed the extra plate weights for. So when you look at the back of this, we see all the cameras on top. That's what had to be taken apart. When Andrew told me that there was a storm coming, he had just checked the weather. To assemble the top part of this mount takes about 50 minutes. It has to be done in a specific order, and everything that I measured and mounted is within millimeters, which means that we can't just pull things off without damaging a camera or another lens. And so I asked him, how close is the storm front? And he said, weather service says 15 minutes. And I thought, there's no way we can take this apart in time. And the reason I had to think about that was because the optical gear and the camera bodies are not waterproof. So if we get water in them, then we don't have clear images anymore. And also the lens is ruined until it can be repaired. So back to our portable outhouse. We had brought garbage bags with us and a lot of duct tape. And so we decided to tape the garbage bags together and drape it over the mount, tape the garbage bags to the legs and over this portion right in the center, which is the actual tracking portion of the mount. If we keep water out of there, we're good. And so it took us about 17 minutes. There was a little rain that started to fall, but we had the top portion covered already and all of the seams duct taped. And so the storm lasted about an hour and 30 minutes. And when the storm was over, we uncovered everything and there was not a drop of water on any of the gear. So we're very happy about that. The portable outhouse was a great idea. For the 2017 eclipse, totality is only 2.5, or was only 2.5 minutes. You'll notice in this picture in the bottom right, you'll see a bunch of cable releases at the bottom hanging. The reason for that is it takes time to find the button on each camera. In addition to that, we don't want to push a button on a camera that's on a mount which is tracking, because that could also cause vibration and then the image would be blurred. And so we trip the shutter with cable release at the bottom. The cable releases are not part of the mount, and therefore we minimize the vibration. In addition to having all of the cable releases in one place, it allows me to, with two hands, control each of the two cameras and release them as fast as I possibly can, which allowed us the maximum number of images during totality. So the owners of the RV park thought that we were from NASA, and they had some orange cones and they put up some caution tape so that no one would come back there and want to look through as we were working. You'll see that this right here is one of the people who came with me. That's Agent Smith from The Matrix, if you've ever seen The Matrix. And so I do apologize. That's not really Agent Smith. That's just my friend Dave. And then seated is Andrew. And both of our wives have said that we're not allowed to discuss projects anymore without them present. This project, as you can see from the picture, we had brought extra tripods. And I had the idea in my mind before we left that there was the possibility in a worst case scenario, what if nothing worked? And we had to put cameras on a regular tripod and attempt to take the pictures without a mount that tracks. I have been traveling out west for at least 25 years, maybe a little bit longer. I belong to a small group of astronomers, about 10 of us from around the country. And all of the astronomers are different backgrounds, different walks of life. One is an investment person, one is a doctor. One woman is an 8th grade algebra teacher, and so on. And so we have all different backgrounds. One of the people who had come happened to be a person who is really big into sound and music. And so one particular year we had met, and we met in one of the national parks, and we sort of circle our cars. And one of the guys who is the sound guy actually put up a set of speakers, and we turned on some music that is a collaboration between two producers and Native American and orchestra. Project is called Anima. It's one of my favorite. And it turns out that we sat watching the night sky for a little bit, listening to this music, looking at the Milky Way from something like Bryce Canyon or Arches National Park. is probably one of the most fantastic experiences of my life. The only experience I can say is greater was walking into a slot canyon on June 21st, the summer solstice, where a Navajo Indian was playing a recorder, which is a native flute, and the sound in that canyon was the most amazing I've ever heard. So what I decided to do here is to place the stages of the eclipse to some music that is from Anima. You will find some other music and a video towards the end. We'll talk about that later. I hope you enjoyed the stages of the 2017 eclipse. So some of the images that you're looking at have several stages with different borders around them. If we know the science and we know how to calculate the time and the estimated beginning and ending of the event, as well as the center, then I can divide that time up evenly through different parts if I know what it is. And if I take a color from inside one of the stages, then I get something looks similar to this and what you've seen. One of the people present today happens to be a friend of mine who teaches art, and she had been passing by my classroom when I was talking about astronomy, and she had poked her head in and talked to me for a little bit. And so I've been talking about, if we know the science, we can create the art. And so I've been talking to her classes now for probably about 15 years, maybe even closer to 20. So the premise behind what we did was to try to find a star behind the corona. And what you're seeing now is an HDR corona, known as in photography as high dynamic range. And we attempted to make two different colors, one on the high side, near the ultraviolet, the blue or purple side, and the infrared, which would be the reddish orange. In this case, you'll notice that nothing really pops out, but it did color kind of interesting. I have a friend whose wall in her house is the face of a cat, and the two eyes are the HDR solar corona. You see the center on the solar disk looks like what they call a cat's eye. This image is my favorite in the entire presentation. That's a lunar eclipse that some astronomy students learned from astrophotography from me. And so that lunar surface was theirs. The next image you're about to see is a physical impossibility. I did it artistically. I took the solar corona and the blood moon from a lunar eclipse, and I combined the two. And so you get an image that looks like that, but you can't have a blood moon and a solar corona at the same time. This one here is a natural image. You can see the inner and outer corona, the bright close ring. And when I was working with the images, we can see a little bit of a halo around the corona. That's in a gamma portion in HDR. Halos are popular. This is a diamond ring in natural light. And as I mentioned, HDR photography of the corona, I also did an HDR of the diamond ring. And you can see here, if you look closely, that the solar disk has shifted just a little bit. And that's because it takes just a few seconds between images to take multiples. So the images that you just saw, none of it was the reason that we had gone to Casper. This is a famous quote in history. And this quote was given by a famous scientist. And I had mentioned to you a moment ago that we were attempting to measure a phenomenon. The phenomenon is known as gravitational lensing and was predicted by Albert Einstein. If you're not familiar with Albert, here is a picture of him. Oh, I'm sorry. That's my cat, Albert. Albert likes beer. This is the real Albert Einstein. And so his prediction of gravitational lensing is that a star very close to a solar disk path of light shifts slightly, and that shift should be measurable. We live in an age where we don't have to do this on photographic plates anymore, and so we can do it in Photoshop. If you think about the solar disk, in the previous images, it was black and the corona was white. In Photoshop, I can take the histogram and invert it. And what it does here is it makes the solar disk white and it makes the corona black. And you see to the right of the solar disk, there's a small circle. In astro imaging, sometimes we get something called a hot pixel. And hot pixels look like a star. It's a little white square on our image that we think is a background star. Oddly, this particular pixel seemed to stay after we removed all of the other hot pixels in the image. And so we thought potentially it was a star. The more and more we look at it, it's definitely a hot pixel, and it probably isn't a star. However, the odd part of it is on a star map, it lines up very closely with a star. The trouble with this is that I need more than one star to do the lensing calculation. It turns out that the prediction has to do with the ratio of the positions of several stars to the center of the solar disk at the moment that the image was taken. If this had worked, then I would have to return 6 months later to the same location and take a picture of the night sky. And then we would overlay those images and look at the original position of the stars on the celestial sphere compared to the stars and where they are, and compared to the shift compared to the stars on the celestial sphere. And so I mentioned to you a moment ago, before I mentioned who was there, I told you that the mount was placed on 3 rolls of toilet paper. So that toilet paper happened to be Charmin. So if you've ever asked if you can squeeze the Charmin, that is true. We never expected to get all those images in such clarity. Let's look at some eclipse comparisons. In 2017, the eclipse was 2.5 minutes. We captured most of the stages, and we had 2 locations with 1 alternate. In this year, coming up 2024 in April, we're going to have 4.5 minutes of totality. We are looking for a high definition video of Bailey's beads, which is a phenomenon that occurs just a few seconds, maybe a couple minutes before totality, before and after, much like you saw the diamond ring on either side of the eclipse. And our options this year are Buffalo, New York, Indianapolis, Indiana, Fredericksburg, Texas, primarily. And we've just recently added Kabul, Missouri. When we had left for Casper, we had traveled as 2 and 2. One of the things that we also had to account for, I did, was electrical power to power the mount and the cameras for the entire event. Because of that, I had 2 batteries that weighed 250 pounds apiece. And so those 2 batteries took up the spot of 2 people in the vehicle. So we had to drive in 2 vehicles. And so you remember that the slide was that we met at the I-80 truck stop. So Andrew and his friend Jimmy had come up from Bloomington, and we agreed to meet at the truck stop. Dave and I drove out here from Northwest Indiana. During the eclipse, Jimmy sort of disappeared, and we didn't know what happened to him. And so we kept working. On the drive home, to tell you when technology works really well, is that we were driving at high speeds, setting up a drop box and sharing pictures between 2 vehicles. And we could actually see the images taken. Well, it turns out that as scientists, when we run experiments and other things, we take data and we look at the experiment itself, but we often don't see ourselves working. It turns out that during the eclipse, Jimmy did not just disappear. Jimmy was taking pictures of us, taking pictures of the eclipse. And so now you get to see us in action a little bit. what you just saw is not a project that comes lightly or that we decided on, basically. Everyone on this screen here is someone in my life who has contributed either to my knowledge in photography, astronomy, or just in general that I'm related to, who helped me by getting me a telescope. When Becky and I were shopping, at times I would be texting or distracted, and she would say, "Let me guess, it's the project." So this first one became the project, and we are working on the project 2.0 for next month. The music, if you recognize both, first was the project I mentioned, Anima. The album is called Grand Circle, and the song for the stages of the eclipse was Mountain of the Sun, which I thought was fairly appropriate. The last song that you heard with us taking the different images was by George Harrison. Comes from the movie Everest, and it's a popular song, Here Comes the Sun. Does anyone have any questions? So the question was, what was the most memorable part of this particular journey? The most memorable part probably was putting the mount on 3 rolls of toilet paper and recognizing that we returned with almost 5,000 images to work through between 12 different cameras. So the question is, generally, things do not move in the sky in a straight line, and how did I get them to work so nicely, I think. Ultimately, the mount that you saw the optical gear on, we had to arrive 2 days prior to the eclipse. The evening of, we have to set the eclipse up in astronomy. We have to align with Polaris. Polaris is the star directly above the Earth, which the Earth spins on its axis. And it does shift a little bit, but we have to account for it. And so we have to align the mount and the counterweight to Polaris. If I do that, then the rotation of the Earth takes care of one of the 2 axes in the sky that I have to track. That means that once I set the altitude of the mount to the right one, then the Earth kind of does the rest. And so what you're looking at in all of these still images is really the Earth tracking the objects across the celestial sphere. And so we have the sun, and planets are known as wanderers, so they don't quite follow the same path as the celestial sphere, the stars in the background. And the mount, because we are able to track the celestial sphere, we can make slight adjustments to the rate at which the mount tracks. And so then I'm able to track other objects in the sky, like the planets or the sun, and so on. It's called polar alignment, and it's done through Polaris, and the mount that you were looking at is known as a German equatorial mount, which is one of the best mounts for astrophotography.
John, we have a question about the 2024 solar eclipse. Can you talk about the path of totality and the best places to view the eclipse this year?
If you recall in the PowerPoint slideshow, I had an exaggerated path of totality. There's a curvature path across the Earth's surfaces that width of shadow is about 70 miles wide. That means that from the center line of the shadow, there's 35 miles north or northwest and 35 miles south or southeast, depending on where you're at. As long as you find yourself somewhere within that 70 miles, you will observe totality as a complete shadow. And so you can look online. There's a place that I use called the Great American Eclipse. It's a nice website. They have good resources and information. You can get books. And the book's not really expensive. It's a very thin book, and it has a map across the United States. And if you know anyone in any of the cities that follow the path of totality, you could stay with them. The one thing I will tell you about going to see the eclipse that was probably the second most memorable thing of this, the owners of the RV park allowed us to stay there with a friend of mine and split his reservation. A lot of places wouldn't do that. They provided us with 3 days at the normal rate, which was $30 a day, I think, or something like that. If you recall last eclipse, there were many places that were charging something like $1,000 a night before the eclipse to be there. And so I can't thank the owners of the RV park enough, because if it wasn't for that, I probably wouldn't have this to share with you. Also, if I didn't have those 3 rolls of toilet paper, a lot of the images would have been blurred. So I'm still back to the toilet paper was the most memorable part of the whole experience.
John, if someone is not a professional photographer, can they still take a decent photograph of the eclipse? And if so, how would they go about doing that?
So a decent image of the eclipse is pretty easy to do. You basically need a tripod, a camera that has an ISO that probably goes up to about somewhere between 6 to 12,000. And what ISO is it increases the sensitivity. Most cameras do this. Most basic electronic cameras today do this. The other thing you'll need is a solar filter for the front. And so what you would do is you would measure the diameter of the lens that you plan to use, and then you'll get a solar filter that's about 4 to 5 millimeters larger than that lens. And normally what you do is you cut a piece of fabric like felt, and you'll place felt around it and you'll slide it on to the front. It should be a fairly tight fit to make sure that the solar filter stays on it. And as long as you're on a tripod that you can easily move on your own, I recommend putting the sun sort of in the center of that image, and also making sure your camera has a cable release. If your camera does not have a cable release, you can set it for mirror lockup. So what that does is on the camera body, you can push one button and you'll hear a sound that the mirror has, you'll hear a click. That means the mirror is out of the way. And then what you'll do is you'll hit the button a second time and it will take the image without the mirror there. The reason you want the mirror out of the way if you don't have a cable release is because by pressing it when the mirror flips up, it causes vibration and will create a blurred image.
Can you talk about the effect that you were at the 2017 solar eclipse to measure initially? Like, what was the purpose? What were you there to do originally?
So the effect we were there to measure, and I mentioned that all of the images you saw are not any of the images we originally intended, which is kind of interesting. What we actually went there for was to take an image of somewhere between 6 to 12 stars in the background behind the corona. So if you recall the image online that had the solar disk in white, and I had darkened the corona, and we had a little circle where we thought that might have been a star, but it turns out it was a hot pixel. In that image, if this had worked, we would have looked for 6 to 12 points of light in that image. Then what we would do is we would measure the positions of those stars to the center of the solar disk. So the image I would have shown you would have been zoomed out a little bit more so you could see the solar disk and the measurement. That would tell us where the stars are on that day at that time of the eclipse. But then 6 months later, I have to go back to the same location, take the stars on the celestial sphere. Then what we do is we overlay those two images and look for a shift in the light and find a way to mathematically measure that shift. And there are two predictions with respect to gravitational lensing. One is Newtonian from Isaac Newton. The other is Einsteinian from Albert Einstein. And gravitational lensing effect correctly predicted is Einsteinian. And so without numbers and mathematics to prove it, we're looking to this eclipse to hopefully capture stars, to actually do the calculation and verify the Einsteinian prediction.
Can you go over the tips and tricks for using a tripod and a cable release when taking photos of a solar eclipse?
Okay, so you'll put the camera on the tripod and you'll connect the cable release. Then somewhere in your camera settings, you'll want to bump your ISO up because you want to increase the sensitivity. The more sensitive the camera is, the faster it will take the image. You want a high shutter speed, probably greater than 1/1000th of a second, and that will help make the sun a still image. The last thing that you'll need is a solar filter. So whatever lens that you decide to choose, you need to select or measure the diameter of that lens, and then you'll select a solar filter that's 4 to 5 millimeters larger. Then you'll get some fabric. Typically felt is used because it's a soft material, so it doesn't scratch the solar filter or your camera lens. And you'll want to build up the felt around it so that the solar filter slides onto it. And that solar filter should be kind of snug to make sure that it doesn't come off at any time during the eclipse. Once you have that, then you can safely look through the camera once the solar filter is firmly affixed to the front lens, and then you could take as many pictures of the stages as you like. In talking about taking pictures from a tripod, you'll notice that the stages that I had here were pretty symmetrical on either side. I'm a huge science fiction fan, and so I like Star Wars and Star Trek. My timer on my phone happens to be Chewbacca from Star Wars. And so what we did was we measured the time of the entire event, and I decided how many images I wanted to take. And so we divided that time evenly. And so I set the timer on my phone. And so every time Chewbacca roared, all three of us were taking pictures at that time. And so if you time it correctly, because the event is even as it moves, then that timing will give you nice symmetry. And that's how you see the stages that have the symmetry. So like I say, if you know the science, you can create art from it. And so that's what I talk about in Marie's class.
To clarify, can you explain more about the felt that you referenced?
Felt is just a fabric that you buy at Hobby Lobby, and you cut it into strips and you wrap it around the end of the lens. And then that, when I mentioned to measure the diameter of the lens and then add 4 or 5 millimeters to it, that is to make sure the filter fits, the solar filter fits over the lens. Then you'll cut small strips of felt from a fabric store, and you'll wrap it around the very end of the lens where the solar filter will fit over it. And once you do that, that creates a snug fit so that the filter does not come off. Not all solar filters are made to the exact diameter of all lenses. They are close. And so oftentimes we have to make up the difference to make sure that the solar filter doesn't come off during any time of an eclipse when you happen to be looking through the camera and through a lens, because it magnifies the light. So the question in person was, is there a filter or something for the cell phone from a reputable place that would make for good images during an eclipse? The one thing I will say about cell phones is that they have come a long way in technology as far as the cameras on them and the imaging. I don't believe the zoom capability is equivalent to large photography lenses. However, you can buy Mylar. Mylar is a type of material that is used to reduce the intensity of the sun, or you could get a welder's glass. And a welder's glass, if you placed it or affixed it to your cell phone, you would be able to point it towards the sun during eclipse and take an image. Now, cell phones generally have a zoom feature. My understanding is that that zoom feature is digital. My experience over several decades is that anytime you have a digital zoom and not an optical zoom, you do not get as clear a picture. Okay, so in photography, I think the trend is still towards the large lenses that are really expensive that gather the light because you get the clarity from them. But it's not to say that you couldn't put a welder's glass on your cell phone and with the zoom capability get a reasonable image. Okay, the other part is there's a human component, right? So if you're holding your cell phone, you have to be able to hold your arm perfectly still, and you have to track it, and any movement in your arm could more than likely create a blurred image. So you would have, if you had a cell phone, maybe that takes multiple images, you would want it to take multiple images as quickly as possible and hope that somewhere in there you are able to hold it still enough that you get a clear, crisp image. Okay, what I'm doing for the next eclipse is reusing the same mount, and we're working on a different variety for capturing the video and the still images of the next eclipse. Okay, so all right, so the question was 2 parts. 1, where am I going to go? And 2, am I bringing toilet paper? So the answer to the first one is we track the weather for 3 months prior to the eclipse. We had decided on the last eclipse to go to Carbondale, or just south of Carbondale, to Vienna, Illinois, because Casper and the Midwest here in Illinois were supposed to both be cloudy. When Friday came just before the eclipse on August 18th and 17, Andrew had sent me a message after I'd been at work for 6 hours. Casper had gotten a clear forecast. And since we were trying to really make a measurement of stars behind the corona, we need a clear sky. And so because I'd already worked 6 hours, I couldn't call off for half the day or go take a half a day off of work. So I had to finish my 8 hours. And then Dave also works with me. So one of us had to go home and get some sleep. And I didn't even have the car loaded because we were just going to go 4 hours south to Illinois. So I told him he should go home and get some sleep. I'll go home and load the car, and I'll pick him up around midnight. So I worked 8 hours. Then I spent another 6.5 to 7 hours loading the car. Then I picked Dave up. He drove first. I slept. And then we left on Friday night at midnight, and we didn't get to Casper until 1 a.m. on Sunday. So it was a 25-hour drive after we had met up. And so Sunday morning, I can't tell you that getting some sleep on that one half of Mark's RV spot was really wonderful. So this year, we're tracking the weather the same as we did in 2017. The problem is weather is extremely hard to predict. And as we know here, the weather from one day to the next is extremely variable. And so what I have to do about a week before is start looking at global weather patterns, meaning out over the Pacific Ocean, what is coming towards the United States. Then I have to look at all of the locations that we have reserved: Fredericksburg, Texas, Indianapolis, Indiana, Buffalo, New York, potentially Kabul, Missouri. We'll see. I have to look at how does the weather front break up? Where is the highest probability of clouds? And somewhere on Saturday, we have to decide where we're going to go in hopes that the weather that comes behind it is clear for at least 2 days. That gives me Sunday to align the mount, and it gives me Monday afternoon to take the images. So I don't know. That's a very complicated answer to I don't know. And in answer to your second question, luckily this time, no, I don't have to bring toilet paper because these are people that I know. So hopefully we'll have bathrooms and we don't have to worry about trains.
Thank you so much, John, for that fun and informative session on the astrophotography of the 2017 solar eclipse. And thank you, everyone, for joining us and for those who are watching.